Hi, I'm April, and I teach math to high schoolers. Welcome to Paper 2 of IB Math Standard Level Analysis and Approaches. In this paper, we are going to go over the following topics: quadratic functions, binomial theorem, financial applications, rational functions, and series and sequences. So if you're ready, take out your calculator and let's do this. Question 8. A stunt motorcyclist makes a jump from one ramp 20 feet off the ground to another ramp 20 feet off the ground. The jump between the ramps can be modeled by y equals negative 1 over 640 x squared plus 1/4 x plus 20, where x is the horizontal distance in feet and y is the height above the ground in feet. Please take 6 minutes and try this question on your own. Question A. All right, this one's easy. We can read our answer straight from the graph. The height of the ramp is going to be 20 feet. B. To find the motorcycle's maximum height, k, above the ground, we can enter the equation in our y equals screen. So let's go to y equals, type in our equation. Oftentimes, what students will do here is they will default to doing things by hand algebraically. It is definitely possible to answer the question that way. You can use the formula x equals negative b over 2a to find the x value of the vertex and then solve for the y value. But it is not necessary. So we can actually just use our calculators to help us answer this question by graphing this function and then looking for the maximum. Here I am fiddling around with a calculator and looking for the correct window so that I can view the whole graph. There's a little bit of tinkering here. I know that the y-intercept is going to be 20. I know that the parabola opens down. So I know that the maximum has to occur somewhere above 20 feet. So I'm setting my y maximum to be 50. And then here we can see that I finally hit a sweet spot when I make the x maximum 500. So once we have a nice window setting here, we can then go to second calc, look for the maximum, and then identify the coordinates of our vertex here. Okay, so we can see from here that the maximum height is 30 feet. And the horizontal distance when it reaches the maximum height is going to be 80 feet. The distance between the ramps. So in order to find this, we can graph another line at y equals 20 and look for the point of intersection between the line and our parabola. And that is going to be at 160 feet. Question 9. Find the coefficient of the term x squared in the expansion of 3x minus 2 over x squared to the power of 8. Take 4 minutes and try this question on your own. So in order to find the coefficient of the term with x squared, I need to use my general term formula. This is not provided in your IB formula booklet and needs to be memorized. So to find the term, we take n choose r, multiply by a to the power of n minus r, and b to the power of r. In this case, our a value is the first term in our binomial, which is 3x. Our b value is going to be the second term in our binomial, which is minus 2 over x squared. N is the degree of our binomial, which is 8. Okay, I don't know what r is, so I need to solve for r in order to find the term containing x squared. So let's plug in all our knowns. We know that n is equal to 8, so I have 8 choose r times 3x to the power of 8 minus r times minus 2 over x squared to the power of r. And I want to set that equal to a times x squared. In this case, a is some real number that's acting as a placeholder for the coefficient that I want to find. So at this point, I'm using the general term formula and I know that I'm missing the value of r. So it is only necessary to isolate the terms containing the variable x in order to solve for r. So I can effectively ignore all of the numbers or coefficients right now. I simply need to figure out what r needs to be. And then once I have my value of r, I plug that back into the general term formula in order to solve for the coefficient that's in front of the term x squared. So if I isolate just the values containing x, I have x to the power of 8 minus r, and then I'm going to have 1 over x to the power of 2r equaling x squared. Now I can use my exponent properties and simplify this somewhat. So on the left-hand side, I'm going to have x to the power of 8 minus r minus 2r. So when I divide powers of the same base, I subtract their exponents. This is going to be equal to x squared. Continuing to simplify the exponent, I get 8 minus 3r is equal to x squared. Now I have an equation where there's powers on both sides. Both of them have the same base, so I can equate their exponents. 8 minus 3r is equal to 2. Let's solve for r. So I find that r is equal to 2. Now what I can do is plug this value of r back into my general term formula and I can, at this stage, solve for the coefficient value. So notice I'm going to need to figure out 8 choose 2, 3 to the exponent 6 times x to the power of 6 times minus 2 squared times 1 over x to the power of 4. Since I only need the coefficient values, really what I'm trying to calculate for the coefficient is this. So I need to plug this into my calculator. I need to plug 8 choose 2 times 3 to the power of 6 times minus 2 squared, or 4 in this case. So let's go ahead and do that. And my answer comes out to 81,648 is my coefficient. Question 10. Miss So deposits 600 Canadian dollars in a bank that pays 3% annual interest compounded quarterly. Assuming that Miss So makes no further deposits, find the amount in her account after 5 years. Give your answer correct to 2 decimal places. B. During the 5 years, inflation was found to be averaging 2.75% per year. Find the real value of Miss So's investment at the end of the 5 years after accounting for inflation. Give your answer correct to 2 decimal places. Let's take 5 minutes and answer this question first. since we are on paper 2, a calculator portion of the test, we can use our graphing calculators to make this much, much easier for us. So I'm going to go into the finance app and use the TMV solver. Now, capital N is equivalent to lowercase n times t. Lowercase n is the number of compounding periods, which is 4, and t represents the number of years, which is 5. So uppercase N has to be 20. My interest is 3. So I'm going to make my PV equal to minus 600 just so that I get a positive future value. It doesn't matter if you made it positive, just know that you'll get a negative value for your future value, but don't write down the negative. It's meant to be positive. And the reason why there's a sign change here has to do with the way that your calculator finds the solution. So just know that one of these needs to be negative in order for you to get a solution. You don't need to know the details behind how that works. So your payment is 0. Future value is what we're trying to find. Our compounding periods are 4 and 4. So we go alpha, solve, and we get an answer of $696.71. Okay, so for part B, the formula for real value is not in your IB formula booklet. So this is another one that you need to have memorized. The real value can be found by taking the future value and dividing it by 1 plus your rate of inflation and raising that to the power of t, which represents number of years. So in this case, our real value is going to be 696.71 over 1 plus, and I have to write the inflation rate as a decimal here. And then let's raise everything in the denominator to the power of 5. So plugging this into my calculator, we get a value of $608.34, correct, 2 decimal places. Question 12. The fourth term of a geometric sequence is 13.5, and the sum of the first 3 terms is 74. Find the first term and common ratio of the sequence. going to start by writing down my knowns. So I know that u sub 4 is 13.5. What I also know is that the formula for the general term of a geometric sequence is u sub n is equal to u sub 1 times r to the power of n minus 1. So in other words, I can write the fourth term as 13.5 equals u sub 1 times my unknown r raised to the power of 3, since it's the fourth term. Notice here that we don't know the first term, and we also don't know the common ratio. So we have two unknowns. And I have two pieces of information that I can use to generate equations in order to solve those two unknowns. Here's my first equation. Now we can use the second piece of information that's given in the problem. The sum of the first three terms is 74. So S sub 3 is equal to 74. I know from my formula booklet that to find the sum of n terms in a geometric sequence, I can use the formula u sub 1 times 1 minus r to the power of n all over 1 minus r. So I can rewrite the second piece of information I've been given as 74 equals u sub 1 times 1 minus r to the power of 3, since I'm taking the sum of the first three terms here, all over 1 minus r. This is my second equation. Two unknowns, two equations. So right now what I'm going to do is I will rewrite equation 1 and solve for u sub 1. That gives me 13.5 over r cubed. I'm going to sub equation 1 into equation 2, giving me 74 is equal to 13.5 over r cubed times 1 minus r cubed all over 1 minus r. We do not need to solve by hand. So now that I have one equation in a single variable, I can use my calculator to help me solve this question. Let's go into our GDCs and actually do that. Okay, so I'm going to go ahead and go into my y equals screen, and I will just enter the right-hand side into y1. So I've got here a fraction within a fraction. 13.5 over, so instead of r, I'm going to use x cubed times 1 minus x to the power of 3. And then in the denominator, I have 1 minus x. And then I'm going to make y2 equal to the left-hand side of my equation. Let's graph this and see what happens. Okay, I need to change my window because I cannot see my equation 2 right now, so I have to set it. Let's go from 60 to 80. See what happens. Perfect. Second, calc. Look for the point of intersection. First curve, yes. Second curve, yes. Great. I have that my common ratio is equal to 0.75. Now that I have my common ratio, we can plug that back in to our equation for u sub 1 in order to solve for my second missing variable. So that's 13.5 over 0.75 to the power of 3, which gives me 32. And I'm done.